Assalamualaikum and greetings to all of you. So as promised, I've made this video to replace our class, and we are still in chapter 6. However, this time we will cover about sorting, right? So this is part 2 of chapter 6. Okay, so we have done covering this part. Okay, now we will learn about sorting techniques. So there are 5 techniques that we are going to learn, which is selection sort, insertion sort, bubble sort, merge sort, and lastly quick sort. Okay, so data in a list may be sorted in either ascending or descending sequence. Okay, let's say we have a list of data. That data can be in numbers or it can be in characters. So ascending means, let's say we have ascending is something that we sort from the lowest number to the highest number. For example, 1 until 10. While descending, we sort from the highest number to the lowest number. Okay, same with characters, right? If the order of the sort is not specified, it is assumed to be ascending. So this is in programming part. Sometimes in a certain programming language like Java, there is a function to sort numbers or characters. It is a predefined function. So if we did not specify the sequence, whether it is ascending or descending, so it will automatically assume that it is ascending, right? So the implementation of sorting varies from dictionary, telephone books, percentage of games won in a baseball game, grade point average for honest students. Okay, so we can implement sorting in this kind of environment, right? If data were not sorted, we would spend hours trying to find a single piece of information, which is true, right? So that's why in dictionary, all the letters are sorted in ascending order. So it makes our life easier to search for specific letters. Through sorting, it will improve the readability of the data while being able to search or extract some information quickly out of that data. Therefore, sorting is the process through which data is arranged according to their values. So these values can be in a form of numbers, or it can be a form of characters. Again, application of sortings, we have dictionary here. So the words are sorted so that searching in a word in the dictionary is easy and fast. And also we have application on, for example, traveling site. Let's say if we want to search for a hotel or booking for a hotel, so normally we will sort the hotel price ranging from low to high. Okay, so this implementation is on numbers. This implementation is on characters. Okay, so we move on with the first sorting technique, which is selection sort. Okay, what is selection sort? Selection sort is an in-place comparison-based algorithm in which the list is divided into two parts, right? The sorted part at the left and the unsorted part at the right. Okay, so this is the unsorted part, the left side of the list here, and then we have the right side, which is the unsorted part. Initially, the sorted part is empty. Okay, initially the sorted part is empty, and the unsorted part is the entire list. So initially when we perform this selection sort, we consider the list as unsorted. Okay, that is for the first iteration. After that, after we perform the selection sort process, okay, we might move some of the elements to the left part of the list to indicate that that element has been sorted. Right? I will show you some example after this. Okay, the selection sort algorithm sorts an array by repeatedly finding the smallest element. So how selection sort works? First, it will find on the first iteration and also on the another iteration. What it will do is it will find the smallest element. Among all of these elements, we have 6 elements here. So it will find the smallest one. So this is the original list, which is unsorted. At the moment, the list is unsorted. So the first thing that the selection sort do is it will find the smallest element among all of these, which is 8. Okay. So what happened after that? The smallest element is selected from the unsorted array and swap. Okay, swap with the leftmost element, and that element becomes a part of the sorted array. So after it has find the smallest element, which is 8, then it will swap with the leftmost element. In this example, the leftmost element is 23. Okay, so what happened? It will swap between these two elements. So 8 will go to here and 23 will go to here. So this is what happened on the next figure. Alright. So after that, we divide between these two lists, okay, through a wall. We have a wall here, indicating that the left part is the sorted part. This is the sorted part, and then the right side is the unsorted part. Okay. This process continues, moving unsorted array boundary by one element to the right. Okay, so it will repeat the same process all over again until all the elements are sorted. Okay, let's move on to the next iteration. So number 8 has been considered as sorted, and then it will again find the smallest element among all of these remaining elements, which is 23. Okay, so 23 will be swapped to the leftmost element. As for the moment, the leftmost element is 78. So 23 will be swapped with 78. 23 go over here, 78 go over here. Okay, so now we have 8 and 23 as the sorted elements. Okay, and then the wall will be moved or will be placed right after the rightmost element that has been sorted, which is 23. Okay, so the wall will be moved, will be placed after 23. So 8 and 23 is the sorted part. The unsorted part is these 4 remaining elements, right? Again, it will find the smallest element, which is 32. So 32 will be swapped with 45. 32 go over here, 45 go over here. Then we have 8, 23 and 32 as the sorted part. And then this wall will be moved further to be placed after 32, right? Again, repeat the same process. So 45 is the smallest, swap with 78. Now we have 8, 23, 32 and 45 as the sorted element. And then the remaining will be 56 and 78. So 56 is the smallest, replace or swap with 78. Now we have the complete list or the final list, which all of the element has been sorted. Okay, so that's all about selection sort. This algorithm is not suitable for large data set as the complexity grows along with data. Let's say we have 100, not even 100, let's say about 10. So even if we want to solve about 10 elements, the complexity is quite high because because it involves a lot of iteration over here. Okay, I will show you the code after this, so you will get what I mean by the complexity grows bigger along with the data. Okay, this is just for 6 elements. Okay, even for 10 elements is quite complicated uh, for us to solve. Okay, and then it will take a lot of times. It is time consuming as compared to other sorting algorithms. So it is suitable if your data or the list is small. Okay, another example, we have 3 1 2 5 6 4. So the first thing it will do is it will find the smallest element, which is number 1. So 1 will be swapped with the leftmost element at the moment, which is 3. Okay, and then okay, the wall should be over here, separating between the sorted and unsorted elements. Again, it will find the smallest element, which is 2. 2 swap with 3. Okay, now the wall will be moved right after 2. And then the smallest element should be 3, right? So because the number 3 is already located at the leftmost, so it will not be swapped with any elements, so it remain the same. Okay, it remain at its place. Okay, so the wall will be moved right after 3, and then smallest element between these 3 is 4. 4 will be swapped with 5. Okay, the wall will go over here, and then 6 and 5, the smallest is 5. 5 will be swapped with 6. Okay, so this is the final result of after the selection sort is performed. Right, so we will go further into the code for selection sort. So this is a function, okay, which receive 2 parameters. Both are int. The first one is the array, and then the size of array. Okay, let's say we pass this array to this function. Okay, contains 12 12 20 12 10 15 2. The size is 5. Okay, so we have a for loop here to iterate between all of these elements. Okay, starting with index 0, we have index 0 over here, 1 2 3 4, and then size minus 1 is 4. 5 minus 1, right? I plus plus. And then we have a variable minimum index to store the current index that store the smallest element. Okay, so at the first iteration, it just assume 0 as the smallest element. It just assume for the first iteration. Okay, however, the smallest element is actually 2, right? But it needs to go through the element one by one in order to find 2. So that's why it just assume the element in index 0 is the minimum or the smallest element at the moment. And then we have the second for int j equal to I plus 1. I is 0 plus 1 becomes 1. Okay, minimum index equal to 0. 0 plus 1 equal to 1. J equal to 1. J less than size is 5. Okay, so it will go the it will iterate for the inside for loop. Okay, Okay, so if array j is 1, right? Array 1, array 1 is 12. Okay, 12 less than array min index. Min index at the moment is 0. Okay, so array 0 is 20. So it will verify, is it 12 less than 20, which is correct. Okay, so what it will do, it will execute the line over here. So I will assign a new value of minimum index equal to j. So j is 1. Okay, so now the minimum index is changed from 0 to 1, indicating that at the moment it has found 12 as the smallest element among all of these. Okay, but still we have another 4 iteration to go. Okay, we just complete the first iteration. Now move on to the second iteration. So 1 will become 2, okay, because j plus plus, right? Size remain the same. Okay, now if array 2, j is 2, array 2 is here, okay, 10. If okay, is it 10 less than array min index? Min index still remain, min index is 0. Is it, oh sorry, not 0, okay, minimum index is 1. Take the latest one, not this one. Okay, take the latest one. Okay, the latest min index is 1. So array 1 is here. So it will verify whether 10 is less than 12. Yes. Okay, so it will execute this line. Now minimum index, the new of minimum index will be equal to j. J is 2. Okay, meaning that after it has come to the second iteration, it finds that 10 is the smallest element. Just now it found that 12 is the smallest element. So if when it moves further, it has found that 10 is the smallest element. That's why minimum index j is at the moment j is 1. Now it will change to 2. So at the moment 10 is the smallest element. So we have another 2 or 3 iteration. Okay, move to iteration number 3. Just now we are in iteration number 2. Now we move to iteration number 3. Okay, array 3 is over here, which is 15. Array min index takes the latest minimum index, which is 2. Array 2 is 10. Okay, is it 15 less than 10? Wrong. Okay, false. So when it is false, it will not execute this one. So minimum index still remain the same, meaning that at the moment the smallest element is still 10. Okay, okay, now it will move to the next iteration, which is 4. And then array 4 is this one, 2. Okay, 2 array min index is array 2 is 10. So it will verify, is it 2 less than 10? So this time it is correct. So what happened, it will change minimum index from 2 to 4. Okay, meaning that now the latest smallest element would be 2. Before this it was 10, but now it has changed to 2, which is at index number 4. Okay, so finish this iteration because it must be less than 5, right? Must be less than 5. So it will go out from this for loop. It will go over here. Okay, now we have a variable temp as a temporary variable to store the elements of array mean index. Okay, mean index, the latest mean index is 4. So array 4 equal to 2. So this temp variable is storing the value of 2. Then what happened? Now it will set the new value of array minimum index, array 4. Okay, previously the value of array 4 is 2. Now it wants to set a new value. Okay, so 2 now is equal to, now array minimum index is equal to array I. I is 0. Okay, so now 2 will become array I. Array 0 is 20. Array 0 equals to 20. So 2 now become 20. Okay, then what happened? Array I is 0. Okay, I is 0. This one. Okay, previously the value of array 0 is 20. Now it will assign a new value equal to temp. Temp is, just now we set 2, right? Okay, so now 20 will become 2. Okay, so this is the latest element, okay, inside the list. So I just demonstrate until this one. So normally after that it will do this part. Okay, so it will try to find the smallest element between these 4 elements. Okay, so it will again repeat the same process. Now I empty, after it has finished this one, the outer for loop, the I will be 1. See, so it will start over here, 12, 10, 15, 20. Okay, it will find the smallest one until the final result will be 2, 10, 12, 15, last 20. Okay, that's why just now I mentioned about this kind of sorting algorithm. The complexity will become high when the size of list is big. Okay, so you can imagine if, let's say, we have 10 elements. Okay, how many iteration it will go through until all the elements will be sorted at the end. Okay, that's why the complexity is quite high if you are using the selection sort. If your list is small, then it's okay. But if the list that you are trying to sort is quite big, then selection sort is not suitable. Okay, move on to the next type of sorting, which is insertion sort. Okay, insertion sort is a simple sorting algorithm that works the way we sort playing cards in our hands. Okay, normally, just at a glance here, we may notice that insertion sort is similar with selection sort, which is true. Okay, which is true, because we have the sorted part and unsorted part. We divide the list into two parts, which is sorted and unsorted, and then also we have a wall. But there is a slight difference between insertion sort and selection sort, which I will explain on the next slide. Okay, so as similar to selection sort, the array is visually split into sorted and unsorted part. Okay, values from the unsorted part, which is the right part, are picked and placed at the correct position in the sorted part. Okay, as compared to selection sort, we need to find the smallest element, right? So let's say if we have 23 here as a sorted element. Next we need to move 8 over here, swap with 78, right? Because 8 is the smallest element. But for insertion sort, it just takes or pick whatever that is located after the sorted element. In this case, okay, we considered as 23, the first element has been sorted. We considered the 23 has been sorted. So we just pick the element next to 23 into the sorted part. Okay, look at this one. Okay, we just pick 78, which is located after 23, to move to the sorted part. Okay, now we have 23 and 78. Okay, so the sorted part must be put in ascending order lah. Must be sorted. Okay, okay. After 78, the next element should be 45. So when we move 45 to the sorted part, we must make sure that 45 sits between 23 and 78. Okay, so now these three elements has been considered, has been sorted: 23, 45, 78. Okay, now again we pick the elements right after 78, which is 8, move to the sorted part. Okay, so 8 should be placed at the leftmost part. Okay, because 8 is the smallest number between all of these. Okay, and then after 78, 32. Okay, so 32 move to the sorted part, so it must sit between 23 and 45. Okay, and then the last one, 56 should be placed between 45 and 78 over here. Okay, so if you notice, for insertion part, we are not trying to find the smallest element. We just pick the element right after the sorted part. Okay, move it to the sorted part, and then we need to place the elements in order, meaning that the sorting is done in the sorted on the left part of the list. Okay, as similar to the selection sort, this algorithm is not suitable for large data set as the complexity grows along with the data. So in the code also, it will involve a lot of looping. So that's why for larger data, it's considered as not suitable. There are other ways of sorting large elements, which I will explain further on the next slide. Okay. Okay, another example, we have 12, 11, 13, 5, and 6. So what happened? It will first, on the first iteration, on the first loop, it will consider as 12 as the sorted part. Imagine we have a wall over here, and then we just pick 11 to the sorted part, to the left part, and then 11 must be placed before 12. Okay, so the wall will move over here. Okay, and then pick 13. So 13 should be placed after 12. Okay, and then 5 should be placed, move it to the sorted part, to the left part, and then 5 should be placed before 11. And then the last element, which is 6, move to the left part, and then that one must be placed between 5 and 11. Okay, so this is the final list that has been sorted. Okay, going to the code part. So this is a function for insertion sort. It receives two parameters similar with selection sort. Okay, given the same example as previous. Okay, size is equal to 5, index 0, 1, 2, 3, 4. Okay, we have variable int key equal to array I. We start with 1, okay, because we consider at the first iteration we consider 12 as sorted element. Okay, so we start at index 1. Okay, int key, it will store array I is 1, which is 12. Then we have int j equal to I minus 1. Okay, 1 minus 1, 1 minus 1 equal to 0. Then we have a while loop. It will verify, is it key less than array 0. Key is 12. Okay, key is 12. Array 0 is 20. Okay, it will verify whether 12 is less than 20, which is true. We have AND operator here, meaning that both sides, okay, the left side and the right side, must true, okay, in order to execute whatever inside this. Okay, so the left side is true. How about the right side? J is larger than or equal to 0. Okay, so J is 0, so this one is true also, so it will execute whatever inside this. Array J plus 1. J is 0 plus 1 is 1. Okay, so array 1 is here. Okay, now equal to array J. Array J is 0. Okay, so what happened is, okay, next, the current J is 0, right? The current J is 0. Minus minus J, so 0 will become negative 1. Okay, because of the J is negative 1, okay, so it will go outside the while loop, which is over here. Okay, because when J is negative 1, it doesn't meet this condition. Okay, J must be more than 1, more or equal to 1. Okay, which is false at the moment because J is negative 1, and we have AND operator here, meaning that both part must be true. Okay, so we won't go for the second iteration. Okay, it just stop over here and then it will go outside, and then array J plus 1, the current J is negative 1. Negative 1 plus 1 equal to 0. So array 0 equal to key. Key is 12. Okay, so what happened now is these two has been swapped. These two element has been swapped. Okay, 12 is located at the leftmost, while 20 is located at the place where 12 is before. Okay, then it will go to the next iteration. Okay, previously we have 1, now the next iteration will be 2. Size remain the same. Okay, int key equal to array I, array 2. Array 2 is 10. Okay, int j equal to I minus 1. Current I is 2. 2 minus 1 equal to 1. Okay, now it will validate inside these brackets. Key is 10. Array j, j is 1. Array 1. We take the latest one. This is the first iteration. This is the latest one. Okay, this is the latest one. Okay, so the latest one just now, 12 is over here at the leftmost. Okay, now array 1. Array 1 now is 20. Before this, array 1 is 12. Okay, now array 1 is 20. Is it 10 less than 20? Yes, correct. And then it will validate whether j is equal to or more than 0, which is true also. So when it is true, it will execute whatever inside this. Array j plus 1. J is 1. 1 plus 1 equal to 2. So array 2 is here. Okay, 10. Now array 2 equal to 20. Array 2, this one. Okay, now it is 10, right? Now it equal to 20. Array 2 equal to array j. J is 1. Okay, j is 1. So array 1 is 20. So now what happened is array 2 now from 10 has became 20. Okay, and then minus minus j, it will become 0. So because it is 0, okay, it will loop again. It will loop again into this while loop because it is 0. Okay, so what happened on the next iteration? Okay, key is still the same. Key is still the same. We are still in while loop. Okay, we are still in while loop. Okay, now array j. We take the latest j, not this j. Okay, don't be confused. We taking the latest value of j, which is 0. So array 0. Okay, array 0 is 12. Is it 10 less than 12? Which is true. And then is it j larger than or equal to 0? Which is also true. Okay, so it will execute this line. Array j plus 1. Current j is 0. 0 plus 1 equal to 1. So array 1 is here, which is 20 at the moment, equal to array j. J is 0. Okay, j is 0. So now array 1, the current value is 20. Now 20 will be changed to 12. Okay. So we have this list at the moment: 12, 12, 20, 15, 2. Okay, so minus minus j, the current j is 0. When we perform minus minus j, 0 will change to negative 1. So because of it is the value is negative 1, of course it will not meet this condition, okay, because j must be equal to 0 or higher than 0, right? So if it doesn't meet this condition, it will go over here outside the while loop. Okay, so what happened over here? Array j, the current j is negative 1. Negative 1 plus 1 equal to 0. So array 0 is here, okay, equal to key. So the current key is 10. Okay, so what happened? 12 will become 10. So this is the latest or the current list at the moment. So again, it will continue the loops until the final result will be 2, 10, 12, 15, 20. Okay, so that's why I just demonstrate until the second iteration, I guess. Okay, yeah, second iteration. Okay, at least you get the idea how it works, right? Okay, now we move to bubble sort. So bubble sort is the simplest one. Okay, among all of the one that we have learned previously, selection, insertion, bubble sort is the simplest one. That works by repeatedly swapping the adjacent elements if they are in wrong order. So this is very simple. It's not complicated as previous. Actually, in theory it's not that complicated. But when we go through the code part, it's quite complicated because it involves a lot of iteration, and then we need to imagine lah. For somehow we need to imagine. But bubble sort is the simplest one. And then the swapping method is executed through the segment below. So this one you have seen this one in selection and insertion sort, which located at the last part of the code. No, sorry, not insertion. Okay, selection. Okay, if you notice in selection, okay, here it is same like this one. Okay, this is the swapping algorithm. Okay, we swap between two elements, right? Okay, again, similar with selection and insertion, this algorithm is not suitable for large data set as the complexity grows along with the data. Okay, let's take a look on this animation. We have 3, 1, 2, 5, 4. So bubble sort, it will compare between these two adjacent elements, 3 and 1. At the first iteration, it compares 3 and 1. Is it it will validate, is it 3 is larger than 1? True. So when it is true, it will swap. Okay, after that we'll compare between 3 and 2. Is it 3 larger than 2? Which is true. So it will swap. Next, it will compare between 3 and 5. Is it 3 larger than 5? Which is false. Okay, when it is false, it will remain at its place. So next, it will compare between 5 and 4. Is it 5 larger than 4? True. So true, it will swap. So this is the last, the final result of the sorted list. Okay, another example, pretty straightforward. It will compare first 5 and 1, so it will swap, because 5 is larger than 1, so it will swap. Next is 5 and 4, 5 is larger than 4, so it will swap. Then 5 and 2, because 5 is larger than 2, again it will swap. And then 5 and 8, 5 is not larger than 8, so it remains the same. Okay, however, the list is still not in correct order. Okay, so it will go through to the next loop. Okay, start all over again. It will compare between 1 and 4. Is it 1 larger than 4? No, still remain. Is it 4 larger than 2? Yes, so it will swap. Is it 4 larger than 5? No. Is it 5 larger than 8? No. Okay, so we have 1, 2, 4, 5, 8. Okay, now the array is already sorted. Okay, this is already sorted, 1, 2, 4, 5, 8. But the algorithm does not know if it is completed. Therefore, the algorithm needs one whole pass without any swap to know it is sorted. So it just run another iteration just to validate or to double check if this list is completely sorted. Okay, so logically there will be no swapping involved. Okay, all the iteration which mean the element is still remain the same. Okay, it won't swap between each other. Okay, just to validate. Okay, just to validate whether this element is completely sorted. Okay, this is the code. Again, similar with the previous sorting method. Okay, so we have two for loops over here, the outer and the inner side. Size is 5. Size minus 1 become 4. Okay, so both start with 0. I and j start with 0. Okay, if array 0 is 20 larger than array j plus 1, 0 plus 1 is 1, so it will validate whether 20 is larger than 12, which is true. So when it's true, it will perform this swap process. So it will store 20 into a temp variable. Okay, and then array j is 0. Okay, array 0 equal to array j plus 1. Array j plus 1 is 1. So now array 0, the new value of array 0 will become 12. Okay, now array j plus 1 equal to temp. Just now temp is 20, so now array j plus 1 equal to temp. J plus 1, 0 plus 1 is this one, so now 12 will become 20. Okay, so this is the latest value of the list. Again, it will move to the next iteration, then it will compare between 20 and 10. Okay, Okay, again it will swap between 20 and 10. So 10 is located at the left side, 20 is at the right side until it finish. Okay, now we move on to merge sort. We have another two sorting technique left. Okay, so this one is merge sort. A merge sort is a sorting algorithm based on divide and conquer paradigm. So what is divide and conquer? Divide and conquer is a strategy of solving a large problem by first dividing. What is divide? It is a process of breaking the problems into smaller sub problems. Okay, we have a in a simple um explanation is something like we have an array over here. Okay, we have array. In divide and conquer paradigm, normally we break into smaller sub problem by dividing. Okay, let's say we have 1 2 3 4 5 6, we have 6 elements. Okay, normally we divide. Okay, divide into separate 3 and another 3. Okay, so this is divide, and then it recursively solving the sub problem. We have learned about recursive function before this, so here we will implement a lot of recursive function. And then conquer is combining the result of the sub problems to produce the result of the larger problems. After it has been break into several multiples array, eventually it will combine it back together. Okay, don't worry if you don't understand at the moment. I will give an example after this. Merge sort divides the list into two halves. It will call itself for the two halves recursively, and lastly merge the two sorted halves. Merge sorts on an input sequence S with n element consists of three steps. First is divide the partition S into two sequence, which is S1 and S2. Let's say this is S, so it will divide into two, become, so the first part will become S1, and then second part will become S2 of about n divide by two elements. So simply just divide. Let's say we have 6 elements here. 6 divide by 2, so we have 3 elements each. Okay, 3 elements each. And then recursively sort S1 and S2, and then lastly conquer, merge S1 and S2 into a unique sorted sequence. So after that, whatever inside this element, we sort it out. Okay, and then after we have sort, we combine it back together. Merge sort keeps on dividing the list into equal halves until it can no more be divided. Okay, let's take a look at this example. Consider the following unsorted list. We have 1 2 3 4 5 6 7 8. We have 8. Okay, we have 8 elements inside the list. So the first thing, we need to divide the list into two halves. Okay, the sequence does not change. At the moment, the sequence does not change. We just separate it to become two separate arrays. Okay, like this one. And then after that, we divide again. Okay, we divide again. Now we have 4 elements and 4 elements. So 4 divided by 2. So next we will have 2 elements each. Okay. Again, the sequence does not change. Okay, and then further divide the list until it cannot be divided, or the size will become 1. And then we divide again. Okay, this one we divide again. 2 divide by 2, okay, becomes 1, meaning that after this it can't be divided. Okay, this is the last division operation that we can perform. Okay, this is the final product. Okay, once the size become 1, which is as each element is 1, the merge process is carried out, and then compare each element with the adjacent list to sort until the complete array is merged. Okay, after the size become 1, after that it will merge back between those two elements. Okay, starting with these two, 14 and 33 will be merged, 27 and 10 merge again, 35 and 19 merge, 42 and 44 merge. But this time when it merge, it will also sort it. Okay, like this one, 14 and 33. Okay, this is already sorted. And then when 27 and 10 is merged, it will do the sorting process together. Okay, and then 35 and 19, so it's sorted. The smallest is the left side, the largest at the right side. Same with this one. So this 42 and 44 is remain the same. Okay, and then what happened is, okay, this one, these two will be merged. These two will be merged, and at the same time it will be sorted. Okay, so what happened when it merged and sorted, the final result will be like this: 10, 14, 27, 33, 19, 35, 42, 44. Again, it will merge between these two elements. Okay, after the final merging, the list should be like this: 10, 14, so 19 will sit between this one, 27, 33, 35, 42, 44. Okay, that is merge sort. So merge sort is simply it works by breaking the list into two parts, okay, into two halves until it can't be divided, and then after that it will merge back together, it will combine back together, but at the same time it will perform the sorting process, okay, during the merging. Okay, another example. Okay, let's say we have this list 8, 3, 10, 5, 4, 9, 7, 2. So we divide it by 2. Okay, on the left part we have 8, 3, 10, 5. On the right part we have 4, 9, 77 and 2 at the right part. Okay, and then this one also divide again. Okay, until it can be divided. Okay, so when we combine it back together, okay, we do the sorting process. So 8 and 3, when we sort it, become 3 and 8. Okay, and then 10, 5, divide until it can't be divided, and then we combine back. Okay, we merge 10, 5, when we sort it, become 5, 10. And then 3, 8 and 5, 10, combine it back together and do the sorting operation, will become 3, 5, 8, 10. Okay, do the right side. So this is the final product, 2475. So these two will be combined back together, okay, and perform the sorting operation. So the final product is this one. Okay, so this is the merge sort, the code for merge sort. I will not demonstrate this one because it's quite complicated. Okay, quite complicated. theoretically is quite easy to understand, but to explain the programming part is uh, quite a challenge, and it's a bit complicated. Okay, and then some more to do the animation is also quite complicated. So I just throw in the code over here. Later on you may use it during your lab, or maybe in your final project. Okay, the last one is quick sort. Like merge sort, quick sort is based on divide and conquer paradigm. It picks an element is as pivot and partition the given list around the pick pivot. Therefore, the list is split into sublists, and these sublists are recursively called to sort the elements. Okay, later I will show you an example. What does it mean by pivot? Okay, what is pivot? Okay, it works by putting elements smaller than the pivot and on the left sublist and larger than the pivot on the right sublist. Okay, let's say we have an array here. Normally pivot is referring to what we call as median, or the center of the array. Okay, the center of the array. So when we have chosen or we have determined the pivot, let's say the pivot is over here. Okay, then we separate the list into two parts, whereby the list or the elements that goes on the left side will be the elements that is lesser than the pivot. Okay, this is a lesser one. This is the biggest one. Okay, on the right side. Okay, bigger than the pivot and then lesser than the pivot. The pivot can be picked in 4 ways. Whether we can pick the first element as pivot, okay, the first element, or we can pick the last element as pivot over here, or we can pick a random element as pivot also can, or we pick median as pivot. Median is center, okay, center as pivot. Like this example, I take the middle or the center as a pivot. So it is quite efficient for large size data. Similar to merge sort. Merge sort is suitable and efficient for large size data, similar to quick sort. Okay, so these two sorting techniques are quite efficient for large size data. Okay, let's go into this example. So for this example, I pick the second method, pick the last element as pivot. So there are 4 ways or 4 methods of picking the pivot, but for this example, I use this one. Okay, the second one, picking the last element, this one, as a pivot. So every method has different ways. So for this lesson, I just pick one techniques, which is the picking the last element as pivot. Okay, consider this following unsorted list: 8761092. So we pick the last element as the pivot, which is 2. Now we need to find element beginning from left, which is smaller than pivot. Okay, just to remember, the pivot is 2. Okay, 2. Okay, 2. So we need, the first thing we need to do is we need to find the smallest element beginning from the left of the pivot. Beginning from the left is over here. So we go one by one. We go over here. Is it 8 is less than 2? No. Is it 7 less than 2? No. Is it 6 less than 2? No. Is it 1 less than 2? Yes. So it has found the smallest element than 2. Okay. And then what happened is we swap the smaller element with the first element in the list. The first element is 8. Okay. So we swap between 8 and 1. Become this one. Okay. 1 is located at the leftmost of the list. And 8 is replacing the placement of 1. Therefore, 1 is considered the sorted element as for now, as for the moment. Okay, so it will continue searching for the smaller element than the pivot. Okay, so it will continue searching. The pivot is still 2. Okay, it will continue from here 7, 6, 8. Now it has found the second smallest element. 0 is less than 2, which is true. So what happened? Swap the smaller element with the second element in the list after the sorted element, which is 1. Okay, so 0 will be swapped with 7. Okay, so 0 now will become the second element after 1. If there is no element smaller than pivot left, swap the pivot with the element next after the sorted element. Okay, if you can see here, starting from 6, there is no smallest element left smaller than 2. There is no element that's smaller than 2 left. Okay, all are greater or bigger than 2. 8, 6, 8, 7, 9, all are bigger than 2. So what happened? We just swap this pivot with 6. Okay, 6 is the next element after the sorted element. At the moment, the sorted element is 1 and 0, right? Next after 1 and 0 is 6. So we take the pivot, swap with 6. So now 1, 0, 2 is considered as the sorted element. 8, 7, 9, 6 is considered as unsorted at the moment. And then what happened is it will repeat the steps with the left and right sublist. Okay, so this pivot will separate this element into the left and right part. The left part is 1, 0, and then the right part is 8, 7, 9, 6. Okay. Okay, so it will repeat the same process again. Okay, so it will pick for the left part, it will pick the 0, the last element, as a pivot, which is 0. Okay, because there is no smaller element than 0, therefore swap 0 with 1. Okay, this is a pivot, right? So the first process is to find any smaller elements than 0. Because there is no element smaller than 0, it just swap between 0 and 1. Now this one has finished, completed. It's considered sorted. So this is the left part. Okay, this is the right part. Again, it will choose the last element as a pivot, 6. Okay, so again it will find the smallest element, than 6. Okay, because there is no smaller element than 6, therefore swap 6 with 8. Similar like this one. Okay, so 6 will go to the leftmost element, and then 8 will go to the rightmost element. So now 6 is considered as sorted element. Okay, this is considered as sorted element. Now what happened? it will break into another list. So 6 is considered sorted. The remaining unsorted element is 7, 9, 8. So what happened is it will repeat the remaining sub list. 8 is a pivot, and then the smaller element, which is 7, smaller than 8, is 7. So 7 is smaller than 8. However, it is also the smaller element at the beginning. Therefore, swap pivot with the second element, which is 9. Okay, because of 7 is already located at the leftmost. Okay, because we want to sort, logically the smaller element should be located at the left side, right? At the left side. So because this one is already located at the left side, so what happened is this pivot will just be swapped with 9. Now we have the sorted elements of the list. Okay, so by combining it together, the final result will be 0, 1, 3, 6, 7, 8, 9. Okay, similar like selection sort, after it has sorted out, it will combine it back together. Okay, finish. So for quick sort, I do not prepare the code for you because it's quite complicated. It is enough for you just to know the theory behind it, how it works, right? So I hope you understand about the sorting methods. Maybe starting from now, you may implement one of the sorting methods to your final project. Okay, and I hope you have already started the final project from now on, because I think we have another 3 or 4 weeks left, okay, before the due date of the final project. I hope you have started, and then if you have any further question about this topic, then you may ask on our group, or you may just private WhatsApp me. Again, I hope all of you understand what have been discussed in this lesson. If you find that you are not understand on some part, maybe you can just repeat this video. Until then, we'll see you on next week, and assalamualaikum, and have a nice day and keep safe.